So question 3 related to the alternative to practical questions from time period. A student uses a pendulum to determine the value of acceleration of a free fall or acceleration due to gravity. Figure 1.1 and 1.2 shows the apparatus. On the figure, what you have to do, you have to measure the length of this pendulum in centimeter. So in exam, you just have to, these are the straightforward questions. So in exam, you'll place your ruler or the scale next to this and measure the length. For example, this one is 0, then 1, 2, 3, 4, and so on. So what you have to do, you have to just place your ruler next to it, this, and measure the length of this pendulum. And that is in centimeter. Like sometimes they ask in millimeter, sometimes in centimeter. So if it is in centimeter, you will read your scale or the ruler in centimeter. Say this is 4.1. So I write 4.1 centimeter. Like, so this one is 4, and after 4, one line is there. So 4.1. So this will be 4.1 centimeter. Then student adjusted the pendulum and the new length, and its length is now 50 centimeter. The length L is measured from a center of the bob. Explain how the student avoid a line of sight or a parallax error measuring a length. So how student can avoid a parallax error? Like, for example, student is measuring a length of this pendulum. He want to avoid a parallax error. So what he should do to avoid a parallax error, he should look perpendicular. So whenever we want to avoid a parallax error, we should use, like, the ruler should be next to the pendulum and we should always look perpendicular. That's how we can avoid a parallax error, because if the scale is just next to the pendulum, it will be easy to recognize the position. So answer for this one, how would explain briefly how the student avoid a parallax or a line of sight error when measuring a length. So place the scale or the ruler or a meter rule next to the bob, pendulum bob. And the second thing, what he should do, he should look perpendicular. Because if he places the scale or the ruler next to this pendulum bob, but he's not looking perpendicular. So in this case, if he's not looking perpendicular, so this is not the right position of the eye. We should always look perpendicular to avoid a parallax error. Is it clear? The second part, that how a student can avoid a parallax error. The next question, a student displays the pendulum slightly and release so that it swings. He measured the time for 20 complete oscillations. So this is the time for 20 oscillations. We need the time period. How I can get the time period? What will be the time period? So for 20 oscillation, it was taking 27.8. I need a time period for 1. So because there are 20 oscillations, so total time divided by number of oscillation. And whenever you write your answer, you should always write in 3 significant figures. So when 27.8 is divided by 20, what will the answer? It will be 1.39. So I will write 1.39, and don't forget to write the unit. That will be second. The next one, measuring a time for a large number of oscillation rather than one oscillation give a more accurate result for a time period. Like if I measure a time for 10 oscillation or 20 oscillation, I will get a more accurate result as compared to if I measure a time for one oscillation. suggest one practical reason why measuring a time for 200 oscillation rather than 20 oscillation may not be suitable. Like, we know that if we increase the number of oscillation, like count the vibration for more oscillations, we'll get accurate time period. But their question is, if a student try to record vibration or 200 time for 200 vibration, then the time period will be small t, like the total time divided by 200, he will get the time period. But why 200 oscillation practically is not a good thing? Yeah, that's good, Adam. Like, what might happen? The pendulum might lose its energy and eventually, even before 200 oscillation, it might stop. That is one thing. What is another? Yeah, because it won't move for 200 times. That's the point. Like, it maybe chance is there or possibility is there that pendulum might not stop before completing 200 vibration. Or the thing is, student might lose the count. Like, you have to count till 200 oscillations. So maybe the pendulum might vibrate for 200, but you might miss the count. So the practical difficulty when you are doing for 200 oscillation, that one is the pendulum might stop before 200 oscillations, before completing 200 oscillations. The second thing, you might miss the count. Like, when you're counting till 200, maybe you miss any count. And then again, even if you miss a single count, you will get a wrong result. Is it clear? Part 3, part 2. Any doubt in this? Then the next one, we need a t square. In paper 6, then you don't have to memorize any formula. You just follow the instruction. So we need t square. What was the value for t? When we got the value for t was 1.39 second. So what is t square? So t square means square of t. So it will be 1.39 square. What is 1.39 square? What is the answer for 1.39 square? $1.9321. So like the final answer is 1.9321. But when you write your final answer, you should always write in 3 significant figures. So I will write as 1.93, and the unit of time is second. So time square will be second square. So it's important that you write the unit. If it is not given, you have to write the unit. So 1.93 second square. So we just have to square the time period. The next one, calculate the acceleration of a free fall by using a formula that 4 pi square L over t square, and give your answer. So how to get this result? According to the formula, the gravity is 4 pi square L divided by t square. So we have all the values. 4 is there. What is the value of the pi? Pi is 3.14 and then square. What about length? And t square we already worked out, that is 1.93. What about length? As you can see in the question, beginning of the question, as it is a continuation, the length was 50 centimeter. But we have to convert into meter because the final answer should be in meter per second, as you can see here. So we have to convert the centimeter into meter. So 50 centimeter equals to 0.5 meters, because 50 divided by 100. So when we substitute this, what's the final answer? So 3.4 multiplied by 3.14 square multiplied by 0.5, and then the final answer is divided by 1.93. So we get 10.21, or we can say 10.2 meter per second square. Here units are written, so we don't have to write any unit. If the units are not there, in that case we have to write the unit. Is it clear, this question? So in paper 6, you don't have to memorize any formula. The formulas will be there. The important thing is value substitution. So you have to learn the value substitutions. Then in part D, the student checked the value of acceleration of a free fall. In the textbook, it is 9.8. And the student answer is 10.2. Suggest a practical reason why the results obtained from the experiment may be different. Like why a student is getting a different answer, like actual answer should be 9.8, but student is getting 10.2. So what might be the reason? Because student is measuring a time period. And when student is measuring a time period by using a stopwatch, so what is the difficulty? That student did not react quickly, or reaction time is there. Yeah, it took time to react, or error, or there is a mistake or error in the time period due to reaction time. Then suggest to improvement in the experiment. So what we can do, if we want to improve the experiment, so we can, the experiment, because it's done only one time, we just measure the length one time and we did the experiment. So we should repeat the experiment, use electronic stopwatch, repeat the experiment, or change the number of oscillations. So if you want to improve, we will repeat the experiment with the different lengths. And to avoid a reaction time, we can use a digital timers or light gates. That's how we can improve this experiment or get a more accurate result.